Okay, now along comes Thomas Kuhn, and he says, look, the empiricists have not been empirical enough. Following Fleck, remember Ludwig Fleck in the Thought Collective? Kuhn says, no scientist is an island. A person who works alone is perceived as a crank or a maverick in science. Scientists are fundamentally all about working in community with each other, sharing ideas, sharing techniques, sharing values, sharing theories. They don't work in an isolated way. Science is a communal practice. It happens in a community. And what Kuhn points out is that scientists don't just share theories, they share values, beliefs, and practices. And he said we need to study all of them. We need to have a fine-grained, historically informed study of how scientists actually work in community. And he came up with some of the most important, most influential ideas in the history of science. He's someone who everyone reads, whether you're an academic in the humanities or in the sciences or in the social sciences. If you haven't read The Structure of Scientific Revolutions, well, you're a very unusual bird indeed. It is one of the most cited and most widely read academic books of all time. It has been cited 122,000 times. I taught something about this book about a year and a half ago. That number has gone up 10,000 citations since the last time I taught this. So that's just in a year and a half. This is a very influential book. If you look at Google's Ngram, this is a really cool thing. I recommend checking it out. It can show you the rate of occurrence of a word in a particular language in the books that are currently digitized. And if you look up paradigm in the English language, you'll see that it's basically not really used very much. And then starting in the mid-60s, there's just this sort of meteoric rise. And right here in 1962 is where Thomas Kuhn published The Structure of Scientific Revolutions. So that doesn't prove that he was the cause. It's obviously just a correlation, but I don't know what else the cause would be. Anyways, so the talk about paradigms is ubiquitous now, and you really encounter it a lot in business. And this is a scene from a movie that I like. It's kind of an old movie now. But the guy, is this sort of corporate executive, says, this phone is a new paradigm. And it's like a little dino phone. It's supposed to market mobile phones to children. And no, it's not a new paradigm. So what I want to do here is talk to you about what the word paradigm actually means. So I'm going to say what Kuhn meant when he talked about paradigms, what normal science is, which is another really important Kuhnian term, what revolutionary science is, and what a paradigm shift is. So we'll start with paradigm. Kuhn used the term paradigm in two senses, and I'm going to distinguish them for you by making one lowercase and in black and one uppercase and in red. So the lowercase in black, that's paradigm in the narrow sense, and the uppercase paradigm in red, that's paradigm in the broad sense. So in the narrow sense, a paradigm is an exemplary instance of scientific research. It is the application of a new theory to solve an important scientific puzzle. So that's what Kuhn means when he talks about a paradigm in the narrow sense. So it's this sort of flash of insight, this moment where you come up with a new theory to solve an existing scientific puzzle. So how do you move from paradigm in the narrow sense to paradigm in the broad sense? Well, a paradigm generates a lot of excitement. When people see it, they say, oh yeah, that's how science is done. And people get excited. And around this excitement and enthusiasm, people start to rally and basically use the exemplar as a sort of foundation for future research. And then a paradigm is the consensus that usually quite gradually grows around a paradigm. So a paradigm is an exemplary instance of science, gets everybody excited, they rally around it, they start using it to solve other problems, and as they solve more problems, a consensus builds. And that's big P paradigm in red. That's paradigm as people typically use it when they're talking about Kuhn. So how does that work? Well, a paradigm, as we said, it applies a new theory to solve an important scientific puzzle. Then other scientists will use the paradigm to serve as a model to solve other puzzles, and they further flesh out the theory. And progress in science is essentially this growth of the stock of puzzle solutions. So the more puzzles you solve, the more consensus builds, the more you move towards this big P paradigm, this sort of scientific collective. And this kind of progress is only possible if the scientific community commits to a shared set of theoretical beliefs, values, practices, methods, instruments, techniques, and metaphysics. So it's not just a shared theory. It's a whole shared way of practicing science. These shared commitments are what form what Kuhn calls a paradigm in the broad sense. And the gradual accumulation of puzzle solutions within a paradigm is what Kuhn called normal science. And that's the science that people are used to. And if you go on to do a PhD, that's the kind of science that you will probably do. It's very unlikely that any given individual is going to be there in that moment in history when a new scientific paradigm emerges. What most scientists spend their career doing is solving small puzzles within an already existing paradigm. And that's what Kuhn called normal science. Normal science is conservative. It's not trying to sort of change anything in the overarching framework. It just wants to solve important puzzles within that already existing framework. So it doesn't falsify the sort of overarching framework or the paradigm in the big P sense. It tries actually to shore it up by using it to solve more and more problems. So an example of this is Aristotle's solution to the puzzle of motion. So he defined motion as an object in motion will tend to come to a halt because the elements composing it reach their natural place in the universe. So that was Aristotle's definition of motion. People saw that and they said, yes, that is awesome. That seems to really explain how motion works. Let's do more science like that. And so Aristotle put this definition of motion forward, and it was a new paradigm, right? The application of a new theory to solve a difficult puzzle. And it was in his work On the Heavens, 350 BC. And people said, yes, let's have more like that. That's an exemplary instance of science. And inspired by that paradigm with the lowercase p, others used it to solve other puzzles and to sort of flesh out the theory. And gradually, a community committed to shared theoretical beliefs, values, practices, methods, instruments, techniques, and metaphysics emerged around Aristotle's initial definition of motion. And this became the Aristotelian paradigm. It was a whole view of everything in the universe and how it worked, right? Everything in the known universe, which was the solar system. And the Aristotelian paradigm was a consensus in science for roughly 1900 years, from 350 BC to 1600 AD. So there's Aristotle looking very proud, and rightly so. 1900 years of consensus isn't bad. That, at least, is the Kuhnian story. That's one way that Kuhn sort of tells this story about how you move from a small p paradigm to an uppercase P paradigm. So